All right, Algebra 2. We're about to start into our next chapter here, which is kind of a total change of pace. We're coming out of logarithms, and we've been doing a lot of algebra all year, solving equations and so forth. In this next chapter, we're going to a totally separate branch of math. Not totally separate, but very different, and going to be talking about statistics. So we want to start, it's going to be a fairly long chapter, and we want to start by laying foundation with some basic terminology, definitions, review some basic techniques and items that I'm sure you've learned about in past courses. So let's just start with some basic definitions here. And in this first section, we're just going to focus on how to collect data and a little bit of how to represent data, a couple of different ways of drawing diagrams and those kinds of things. Hopefully, most of what we do is going to be pretty familiar from past courses, but I'm sure some of it will be new and we'll have a variety of experiences. So um, we need to make sure we have all this kind of same foundation before we go forward. Also, it's a really great chapter to help you get a little bit of a taste of some of the stuff that we would cover in AP Stats. And this chapter is all foundational prerequisite stuff that you would need going into an AP Stats course in the future. So starting off most basically with the definition of what we mean by statistics. So statistics is the science that deals with the collection, organization, summarization, and interpretation of related information called data. So yeah, hopefully that's basic and we already all understand that much at least. It's essentially just the science of data, the collection of data, the representation and interpretation of data. Okay, we're going to focus most of this chapter on what is called univariate data or univariate statistics. So when we and univariate statistics consists of one number for each data value. So it's just a single variable, right? Una meaning one, variate meaning variable. So one variable statistics is what we're going to focus on most of the chapter. Toward the end, we'll do a little bit about bivariate when we have two variables and how we can relate two variables. But we're going to focus on studying just one variable for most of this section, or most of this chapter. So let's talk about some basic methods of collecting data that you're probably familiar with a lot of. We have one called the census. Obviously, the United States government does a census every 10 years. We're currently in a census year, and the census is the government collecting data about every person in the U.S. population. They do it every 10 years, and the goal is to collect, and this is what a census does in general, is to collect data about every single subject. So obviously, the U.S. Census is probably going to fail at getting literally every single person who lives in the United States, but that's the goal. It's a very ambitious project, huge project. That's why we do it every 10 years, a full force of the government behind it, to try to get in touch with and collect key demographic and social and financial and economic information about every person in America is the goal. So that's a census. A survey may or may not apply to every single person, but it's more about the type of data you're collecting. So this is typically written questionnaires, personal interviews, telephone requests for information. You call and ask for information. And this is especially good when you're trying to collect data about experiential information, experiences that people have had, also their preferences and opinions. These more qualitative and ambiguous things are more suited to a survey than, say, eye color or whatever. That's really concrete information. And then there's two really big ones that you've probably talked about in science classes and other places that are really important to understand the difference, and that is a controlled experiment and an observational study. A controlled experiment is when we have it's a structured study that consists usually of two groups. It could be more groups, but the idea is one of the groups receives a particular treatment or has something done to them, or they take a drug, or they're in a particular setting, and then there's another group that's not receiving that same treatment. And then we see how each group performs or measures in a particular variable and see if there's a difference between the two groups that receive different treatments, right? And so the results for each group are compared to see if there's a difference that could be attributed to that treatment. Okay, so this is what's called a controlled experiment. The key emphasis here is that treatments are imposed by the researchers. Okay, treatments are imposed. So the researcher decides what thing will be applied to each group, the control group and then the experimental group. That's the key difference between a controlled experiment and an observational study. An observational study is very similar. We're going to have two groups, and we're going to look at one group has a certain attribute, the other group has a different attribute, but we're just watching, we're observing. So the key difference here is that the researcher does not apply the treatment. Okay, they just observe it objectively from the outside. Whereas in a controlled experiment, the researcher is causing one group to have a certain attribute. In an observational study, they're just standing back and seeing these two groups and seeing what the differences are. Okay, so next, a couple more terminology, or a couple more terms that we want to focus on. So the next important one is called the population. When we say population, in a statistical sense, what we mean is the entire group that's being studied. So the population of a given study is the set of all possible subjects. When the entire population can be measured, that study is a census. So again, the U.S. Census is trying to measure data about every single person who lives in America. So the population is people who live in America, and it's the entire group of every person that lives in America. Typically, or not typically, but in a lot of cases, it's super difficult to contact or get data from every subject in the population. Once your subject gets more than a few dozen or a few hundred people, it becomes really difficult to collect the data. So instead, data will often be collected from a subset of this population, which is called a sample. Right? So the key thing to understand is the population is the entire group of subjects that you have interest in. And a sample is some subset of it. For example, if you were trying to study the average height of students at Cascade Christian, the population, let's say that just a high school, the population is every single student from grade 9 through 12. But it would be pretty challenging to get, it might be challenging to get the actual height of every single student. So maybe you're going to just pick 10 students from each grade to be representative of the whole school. And so that's the idea of a sample, is when it's challenging to get data from every single person, then you'll just take a sample and let that sample be representative of the whole group. So there's a few things that make a sample a good sample. So here are the attributes of an effective sample. 1, they must be representative of the group being studied. So for example, if you wanted to do average height of students at Cascade, you wouldn't want to take a sample of only the boys basketball team, because they are very likely to be taller on average than the typical student, right? So you need a sample that gets all of the different types of people within the population. So you'd want to make sure you have some tall and medium height and short people mixed in so that it's representative of what the whole group looks like. Another is that it must be large enough to be effective. So in a sample of Cascade High School students, you wouldn't want to just sample the 5 friends who are sitting with you at your lunch table, because that's really, even if they were varying heights, it's so small that it's not going to necessarily give you a good representation of the whole group. So you want to have a sample that gets all the different attributes within the group, and then also is large enough to represent the whole group, and most helpfully is randomly determined. Okay, and if this third attribute is met, if the sample is randomly determined, it will typically cause number one to happen. When you take a random sample, you're much more likely to get a group that represents the whole population, rather than having some sort of bias like picking the basketball team or your friends at the lunch table. Okay, and so when we talk about bias, we don't necessarily mean some sort of opinion or subjective thing. What we mean is a bias in statistics is some sort of attribute in the sample or in the data that consistently causes your values to be one way or another not true, right? So if you take a sample of the basketball team, they might not have any sort of opinions or preferences, and we're not talking about that kind of bias, but they will tend to be taller than the typical student. So that's going to give the data bias because you'll consistently be overestimating the actual height of Cascade students. So let's look at an example here of a sample and see if we can evaluate its efficacy. So it says a new medicine intended for use by adults is being used on 5 men whose ages are 22, 24, 25, 27, and 30. The question is, does this provide a valid sample? Okay, so if we look at this here, it says a new medicine intended for use by adults. Okay, that's a very, very large population. It just says adults. It doesn't specify anything about how old those adults are, what their gender is, where they live, what their economic status is. It just says adults. That means all people on the planet who are age 18 and older, right? So that's a giant population. So when we think about, does this sample represent that population well, the answer is no, and it's no for a few reasons. So let's say no. No, it's a bad sample. Why is it a bad sample? A couple of reasons. One, it's tiny. You picked 5 people to represent a population of billions and billions of people. So the sample is far too small. Far too small. Only 5 people. Also, you'll notice they're all in their 20s, or the oldest one is 30, right? And the overwhelming majority of adults are over 30 years old, right? So this is not a representative sample. No one is over 30 in the whole group. Also, this one's a little bit subtler, a little easier to miss. It only says men were selected in this sample, right? Approximately half of adults are females. So if we only pick men, we are not getting a representative sample in that way as well. So let's make this 2 separate points here. No one is over 30. Also, only men were selected. So multiple reasons why this is not a very good sample. You could also add on, well, it doesn't really tell us one way or the other. It just says 5 men were chosen. So it doesn't tell us whether those were randomly selected or not, but probably they weren't randomly selected either. So maybe we could say don't appear to be randomly selected. We can't know that for sure. It's possible that you could randomly select 5 adults that were men in their 20s, but it doesn't seem likely. Okay, so there's just some, getting started here with this section. We've got a lot more terms and practice to do in this section, but that's just to start with some of the basic terminology.